Welcome to today's lecture. Today we're going to be talking about linked lists, or at least we're going to start our introduction to linked lists. So with that, I'm going to break the lectures up a little bit, and there's a couple of topics that we need to cover that are really support material. So things we need to know before we get into linked list code and talking about what linked lists are. So that's going to be type definitions and some more about indirection and pointers. So we're going to cover those two topics first in this lecture, and then the follow-on lectures will introduce linked lists, and then we'll go into some more detail about it. So with that, we'll get started on our very first topic, and that is type definition. So what is type definition? Type definition is something we can use in the C programming language in order to essentially create a shortcut. It's called creating a synonym, and the best thing to do, I think, is just to jump into some code and look at it. So along with trying to break the lectures up a little bit better, I'm also going to try and type through the code a little bit more instead of just jumping into a program right away and making you guys have to figure out what's going on as I type through it. We'll type through it together, and so hopefully that helps a little bit. As always, if you don't think it does, I'm always open to feedback, either anytime throughout the class or at the end of the class when you do the student opinion survey. So with that, type definitions, because they help us to create shortcuts, they work really well with structs, and that also works really well because when we start looking at linked lists, we're going to be using structs. Linked lists are really going to be, potentially they could be the most complicated subject that we've covered all semester, and because they bring together everything that we've talked about. We're going to have structs, we're going to have malloc, we're going to have pointers, we're going to have a second level of indirection, so a pointer to a pointer, we're going to have type definitions. So not only does it bring everything together, it also adds a couple of new elements, and then it becomes a lot more computer sciencey. It becomes a lot more abstract, and that the logic, the flow of the program takes a little bit more to get a grasp on. So we're going to go through hopefully plenty of examples. The code that I'm going to use is right out of the book. The book goes through the program line by line, so that's an additional resource. If the way I'm presenting it isn't helping or making sense, that is another thing you can use. So with all that, let's take a look at creating a structure. So I'll create a struct file, very similar to what we did for one of the previous labs, and then I'm going to just create a handful of members. So we'll call char name and char date. And let's say mode. We'll just do a char mode, and that'll represent either directory or file. So now that I have that struct, let's say that I wanted to declare that struct, initialize some of those members, and print a value off. Well, what I have to do then is use struct file, a file, and I'm just going to use an initialization list to make it easy. So name, we'll say file1.c, date, we'll just say 1900, and for the mode, we'll say F. Okay, now if I want to print that, let's say I just want to print the name of the file. I say I'll use a puts, and we'll say a file dot name. Okay, we'll save that, and let's go to the command line, compile, and see what happens. All right, there we go, file1.c. So that's what we'd expect. Now let's create a type definition. Okay, so in order to create a type definition, you have to use the keyword typedef. Okay, that indicates to the compiler that you are defining a type definition. The next component of a type definition is what you want to create a shortcut for. So in this case, I want to create a shortcut for struct file. So I type in struct file. Now that I've done that, the last component of a typedef is what do I want the shortcut to be. So I'm going to use uppercase F, and we'll just call it file. Okay, it's common practice to use the uppercase F to indicate that it is a type definition. So what we've just created then is we've said, okay, when this program runs, create a type definition, create a shortcut. I want to shortcut struct file, and I want to use file as that shortcut. So now anywhere in my program where I use file, it's essentially like I was typing in struct file. Okay, it's very similar to symbolic constant. Okay, this gets replaced with this, but I don't have to type struct file. So let's try it. Let's create a new variable, but let's use our type definition. So uppercase F file, I'll call this a file2, and file2.c, and I won't initialize anything else. And let's print that off now. So a file2.name. We'll save it, we'll run it, and hopefully our output is file1 then file2. There we go. Okay, so that's really all it is. This then is just a shortcut for this. All right. It can, of course, get a little more complicated. Let's say that I want to use a Typedef to create another Typedef. So I say Typedef, and I use file, and let's say I want to make this a pointer. So now I can say file pointer. Right? This represents that, so struct file, and this makes it a pointer. So now whenever I use file pointer, that's essentially like using struct file pointer in any of my code. So if we were using malloc and we were going to create a struct file pointer, the way that we would do it without a type definition would be struct file, and we can say a file pointer. Cannot forget the asterisk though. Oops. Equals, and then let's see here, we do struct file pointer, malloc size of struct, oops, struct, my goodness, I can't type today, struct file. Okay, the name member is an array, so we have to use string copy, and then I could say a file pointer name and whatever I want it to be. So we'll say this is file3.c. Okay, and now we'll go down here and we'll print that off. A file pointer, arrow operator because it is a pointer, and hopefully I didn't make any mistakes so that when we compile that program and run it, there we have our output, file 1, file 2, file 3. Okay, let's say that I want to use that type definition. That's the whole point of creating that type definition. So what I can do is I can say file pointer, okay, file pointer 2 equals file pointer malloc size of file. Okay, and then same thing, string copy, file pointer 2, and copy that into name. And what do I want to copy? And we'll call this file4.c. Now let's print it off. File pointer to name. Okay, let's make sure this runs, and then we'll go back and look at the code in a little more detail. Okay, no errors, no warnings, and file4.c. So everything worked. All right, so we've created a typedef. We created a shortcut or a synonym for that. Struct file asterisk. We did that right here. Okay, so the combination of these two type definitions allows us to, instead of typing struct file asterisk, just type file pointer. We do not need the asterisk because the asterisk is part of the type definition here. So that allows us again to just kind of to reduce some code. It lends itself to better readability, better maintainability, because all of this file pointer is now wrapped up in these two type def. Okay, so that's what our type defs are, and I'll upload this code so that you have it to look at. If you want to delete it before you watch the video and follow through, that's also a good idea. All right, the next topic then is our second level of indirection. So when we talked about pointers originally, we talked about the fact that a pointer is one level of indirection. A pointer points to a value indirectly, right? If we want to point to that value, access that value, we have to dereference the pointer. But pointers can have multiple levels of indirection. A pointer can point to a pointer, which is the second level of indirection. A pointer can point to a pointer, which points to a pointer, so a third level of indirection. And we're not going to go that far. We only care about a second level of indirection. And we care about that because we're going to use that in our linked list sample code programs and ultimately the lab. And so it'll make, I think, more sense once we get into the code, and I'll explain exactly why you need that second level of indirection there. Let's take a look at some sample code then. So same thing here. We're going to build out our program. First thing you'll have is we already have a struct student. We have one member name. Okay, so we're just going to be using a very simple structure in order to explore the second level of indirection. We already have one type definition. That's struct student, and the type definition that was created then is student. So I'm going to create another type def, but instead of this being one level of indirection, we're going to create two levels of indirection. And I'm just going to call that a student pointer pointer. Okay? It's terrible naming, but hopefully it helps get the idea across that this isn't a simple pointer. This is a pointer to a pointer. Okay? When we want to declare that second level of indirection, we use an additional asterisk. All right, so we've got that type definition. We're also going to look at a function that prints the name. Okay, so void, we'll call this print name, and it's going to be the same thing. It's going to be a student pointer pointer, and I'm going to call this a pointer pointer. Okay? Again, it's kind of silly, but hopefully that just keeps it that keeps it in the forefront of your mind that we're working with a pointer to a pointer. All right. So to get into the main program, then the first thing I want to do is simply declare a student. So we'll use the first type definition. We'll say student, a student equals, and I'll use an initialization list to initialize that to my name. Right? The next thing we're going to look at, well, before I do that, I'm going to finish this function. Student pointer pointer, a pointer pointer. Okay, printf, and we'll say the name is all right, there's something we're going to do here, a pointer pointer, and then access the name. Okay, so what we have to do, because this is a pointer to a pointer, remember that when we dereference something, we dereference it to whatever that pointer is pointing to. In this case, we have a pointer that's pointing to a pointer, which is pointing to the struct. So in order to get to a single level of indirection, in order to get to just that simple pointer, which we can use the arrow operator to access the members, we need to first dereference that variable. Okay, so we wrap this thing in these parentheses. That gives us an order of precedence that says dereference this first, and then once we've done that, then it becomes essentially a pointer to that struct. Then we can use an arrow operator and access the member. Okay, this gives us our second dereferencing, which then directly accesses the member. Okay, so that's the function that we have. We want to work with a pointer. So now that we have our function, we've declared a variable. Let's declare a student pointer. And I'll say student pointer equals memory address of a student. Okay, we've already declared it here. We've initialized the value. We've now created a pointer, and because it's a pointer, we assign it the memory address of this variable. So we can, at this point, simply print. We can print pointer name if we wanted to. And it's probably not a bad idea just to make sure that everything's working the way that I hope it is. Okay, printed my name, so that's good. So far so good. But now we want to ultimately pass that to that function. Okay, so in order to do that, we have to call print name, and we provide the memory address of the pointer. Okay. If we provide the memory address of a pointer, then that provides us with that second level of indirection for the argument of that function. Okay, so let's go ahead and just compile that and make sure that it runs. And there we go, called the function and it printed the name. So here's our pointer. If we get the memory address of a pointer, then we have two levels of indirection. When this value gets assigned to this argument, the value of this is a memory address to a pointer. Here's this guy. The value of that is the memory address to that structure. So let's see if we can look at this in one more way, and then we'll wrap up the lecture. So let's say that I wanted to create and use the second type definition. And so student pointer pointer. Actually, yeah, that's fine. So we'll call this pointer pointer, and now we can set that equal to the memory address of our student pointer. Okay, and then when we call this function, instead of providing it the memory address of this pointer, we can just provide it the value of that variable. Okay, So let's run it, make sure I didn't create any errors, and then we'll go back and look at the code a little bit better. All right, great. Output is still the same. So what did I do? I used the type definition, student pointer pointer, which is using that type definition with 2 asterisks. Okay, so that's what gives us that second level of indirection. We then created a variable called sPointer pointer, and because this is a pointer to a pointer, we have to assign it the memory address of another pointer. We have that right here. So we use the address operator on that variable, and that then assigns an appropriate value to it. Okay, we call print name because this is a pointer to a pointer. We don't have to provide anything else, just the value, and it prints off and works correctly. Now with that, because we have this type definition, what I could have done is I could have used that type definition to define our arguments as well. So I could have said a student pointer pointer and not had that student pointer asterisk asterisk syntax. So we'll make that change and we'll compile the program. Still works. Okay, so you can see it was the same exact thing. I just didn't do that until we walked through the code, just to make sure you understood that that is in fact a pointer to a pointer. Okay, so that's all I wanted to cover with this lecture. If you have any questions, then let me know. We will spend more time with the second level of indirection, pointers to pointers, inside of our linked list. So if it's not quite or entirely clear what's going on here, hopefully by the time we get through our linked list, it makes more sense. You just have to keep in mind, it's really rather simple. A pointer to a pointer. If you have a pointer to a pointer, you have to assign it the memory address of a pointer, which is what we did here. And when you want to dereference that, depending on what you want to do, if you want to actually access the data, the structure that it's pointing to, because there's 2 levels of indirection, we have to dereference once with an order of precedence, dereference it once in order to make it a pointer, and then use our appropriate error operator to access the number itself. So, all right, let me know if you have any questions, and see you at the next lecture.